All right, so when we looked at this earlier this week, the problem kind of just looked like this, right? And the directions were simplified. So when those were the directions, what did we have to do in this problem? What did we have to do here when the directions were simplified? We had to do two things. Haley, what's one of those two things? Or did I kind of... Anytime. Okay, but before we solve the equation, I want to simplify the left-hand side. So what does that mean? What do I want to do here? Lila? Okay, the first thing we want to do is distribute. And then... Hannah? Not yet. After we distribute, we got to do something to still simplify it. Yusuf? Combine like terms, right? It's not always adding. We might also have to subtract, right? But we're going to combine like terms. So we're going to distribute, combine like terms. Right now, we have all these different terms. I don't want all those terms. I don't want it to look so scary. All right, so I'm going to have less terms over there if I multiply, which is the distributive property, and then combine like terms. All right, so anytime you see the parentheses like this, all right, take whatever's in front of it and make your two lines like that. That'll help us remember, okay, we need to do that first. We need to distribute first. So what do we do with this 2x? Sebastian?
2x.
What?
2x?
Yeah, I'm talking about the 2x. What do I do with the 2x? Nothing?
Oh, I don't know.
Oh, I thought you said nothing.
No, I thought you were talking about the parentheses.
Oh, no, I'm not there yet. I need to know what to do with this. Sebastian!
You have to...
So this is the second time you raised your hand. I called at you. And then you're like, wait, hold on, never mind.
Maybe get it ready to add to the other.
We are going to get it ready to do that. By getting it ready to do that, we're just going to rewrite it. We're going to rewrite the 2x. We're not doing anything with that yet. Just like when we did order of operations. We had all these operations that we're not doing yet. We just bring it down and we do it later. We're bringing that down. We're going to do it later. We're doing this now. We're multiplying right now. Negative 3 times x. Negative 3x. Negative 3 times negative 1. Positive 3. Multiply those and put it there. Multiply those, put it there. Multiply those, put it there. Pay attention to your signs, please. Last period, walking around. Lots of negative signs when there should be positive signs. Lots of positive signs when there should be negative signs. Negative times a negative is a positive. Positive times a negative is a negative. Okay? What are we doing with that 4? Nothing yet. Bring it down. Plus 4 equals negative 10. So we did the distributive property, like Lila said. Then we combined like terms, like Yusuf said. No, we didn't combine like, oh, that's the next step. Combine like terms. Sebastian, what's up? Oh, you want to do it? Okay, what are we combining?
2x minus 3x, which makes it negative 1x.
2x and negative 3x is negative 1x.
And then 7 plus 7.
3 and 4 plus 7 equals negative 10. All right? Subtract 7. Now it's like every problem we did the other day. We got an x term, we got a number, we got another number. We need to undo operations. Undo operations. Send map. Add or subtract something to the other side first. Haley. Minus 7, minus 7. Good. Now we've got a negative 1x and a negative 17. This is negative 1 times x. Now we're multiplying or dividing something to the other side. Yeah, hold on. Trying to remember. I'm drawing a blank. Ashley. Yes. Okay, Ashley, what? Divide both sides by -1. Divide both sides by -1. X equals 17. I think one of the harder parts about me remembering names this year is the masks. Like I don't see like a full face to get like a, like I have a couple kids in my other class, they like wear a hood, and then they got glasses on, and then they got their mask. It's like what does that person look like?
One day I'm gonna wear a hood or a mask or my glasses.
They don't even know who you are.
Black glasses.
I don't know if that's allowed. Are sunglasses allowed? But what if you had those? What are those glasses that change light in the sun?
Oh, yeah.
The transitions, right?
Yeah.
What if you just came in from outside? They'd be like darker.
These are the ones that change in the sun.
Are they?
Yeah.
Yeah, my dad has those too. They're like, and he'll be inside. Well, yours are always. I guess it's only in the direct sunlight. It's not if it's like super bright in here because this is a super bright room. Okay, where am I? What are we doing? Oh, algebra. Who's distracting me? Me? I was distracting myself.
Yeah.
All right. Any questions on the first one? All right. Do another one just like it. So similar steps. We have to do the same thing. We have to distribute. We got to combine like terms, and then we need to solve it just like we did all the other problems. All right. Here we go. You know what? You guys try this one on your own. Let's start that now. What's everyone's first step? You can talk about it and then do it. What is somebody doing? Just yell it out.
Distribute.
What are we? I know we're distributing, but what are we distributing?
5 into x and -3.
Okay, the -5, right? Remember what I said? Just like I said over here. You see parentheses over there like that? Oh, I see these parentheses over here. What's in front of it? Whoop, whoop. That's first.
Why wouldn't you do multiplication?
That is multiplication.
I mean,
Distributive property is multiplication.
I'm not subtraction because there's sad enough in the first thing.
No, SADMAP is when you're solving. Are we solving yet?
No.
We're not solving until we simplify. Right now we're simplifying. So the first step is to simplify this side. After we simplify, now like this stage right here is where it's simplified. Once you simplify it, now we start undoing operations. Understand? Make sense? All right, good. Now what's up?
I want to find like terms that are linked to each other.
You just look at the signs in front. So it's a -5 and a -2. Fractions or numbers too? You don't like fractions?
So I used to do that.
Yeah, just leave it like a fraction. You didn't distribute first. When did you get the 3x? You did the 8 minus 5 first. You got to distribute the 5 first. Multiply first. That's why I made those 2 black marks on the top of it. No, not yet. You add or subtract something to the other side first. Bring the 23 to that side first. Yeah, you made your answer like that. I can't really see it. 31.70. Oh, you mean the mixed number part? Should be.
It's 28 over 4 times 7.
Where are we at over here?
Because
-5x, but that's -5 times -3. Multiplication. Let me see yours. 5x, negative times a negative is a positive. Then you're going to combine like terms. Why do you go to 3? It's a -5 and a -2. So that should be a -7. When the signs are the same, you add. How's it going over there? You done? Scared who's ever like watching. That's what I used to do on Zoom all the time. I would just be like right in the screen. All right. Again, make sure you take care of the negatives. I saw some people mess up with the negatives here. Bring the 8 down. 8. -5 times x. -5x. This is multiplication here, people. Multiply. When you multiply negative times a negative, you get a positive. -5 times -3 is positive 15. -2x equals -8. Now, we're not moving anything to the other side of the equation yet. We're still just simplifying. Combine like terms. We're adding and subtracting. A -5 and a -2 is a -7. An 8 and a 15 is positive 23. Did you mess that part up?
No, I just did the wrong side because I did the -23 minus -8 by accident instead of.
Now it's simplified. There's only an x term and a number on that side. Now we can undo our order of operations. Sebastian, what's up?
Subtract 23.
Oh, yeah, you're giving me an answer? Yes.
Yeah.
-23. -23.
-7x equals -31.
All right, slow down. Okay, so that's what you get after you subtract, right? We added or subtracted something to the other side. Now we're going to multiply or divide. It's -7 times x. To undo it, divide by -7. Good. Couldn't grab my marker. You can leave your answer like that. A negative over negative is a positive. 31/7. There you go.
What if I made a big number?
Awesome. What is it? 4 3/7?
Yeah.
Okay, I don't care if you leave your answer like that or you give your answer like that. Okay? All right. So that's what we ended with yesterday. We ended with solving equations where you had to simplify first. It's called a multi-step equation. The next thing we're going to look at is equations with variables on both sides. So number 3 is going to have variables on both sides, right? What kind of equations? What kind of equations? I said. What kind of equations do you know how to solve? When the variables are where?
On both sides.
You know how to solve them when they're on both sides?
Yeah.
We didn't do that yet. Maybe you know how, but that's not what we did. What have we been doing? We've been doing them on one side. Now, left side is most of the times we're put it on that side. So if we've already know how to solve equations with variables on one side, let's make this an equation with variables on one side. They're on that side and that side. I don't want them on both sides. I only want them on that side. So I'm going to move one of the variables to the other side. Which one do you want to move?
3.
It doesn't matter. You can pick one to move it. I want to move that 3x over there.
Yeah.
How do I make it disappear from this side?
Subtract.
Just use an eraser?
No, subtract 5.
Okay, right. Right now it's a positive 3x. If I subtract 3x from 3x, what do we get?
No.
0. It's gone. Where did it go? Well, it didn't go anywhere yet. I have to do it to both sides of the equation, right? So if we subtract 3x from this side, we have to subtract 3x from this side. We're doing opposite operations to move it to the other side. It's a plus 3x, so now we subtract 3x. Keep everything in line. 8x minus 3x is 5x plus 5 equals, now it's gone. We moved it. So now all we have left over here is a negative 7. Now it's just like the other problems. We're right here, look. Variable plus a number equals something. Variable plus a number equals something. Variable plus a number equals something. Once we get to that step, undo operations. Haley? We're adding 5, undo it, you subtract it. We get 5x equals negative 12. This is 5 times x. To undo it, divide. Divide the left side by 5. Divide the right side by 5. Line the screen. X equals, you can leave it as negative 12 fifths. I don't care. Negative 12 fifths. Or, how many times does 5 go into 12?
2.
Twice. So negative 2.
2.
And there's 2 left over, negative 2 and 2 fifths. Okay? So it's the same process, except we got to move the variables. Move the variables from one side of the equation to the other side of the equation. Okay? I'm throwing in there now a little bit of what we did first. What do we do first? What's that? Can't hear you. What? Parentheses, yeah. Okay, so what does that deal with? What's the mathematics stuff that we're doing? Ooh, you almost We want to very good. We want to simplify the left-hand side. Okay, what Haley was talking about was getting rid of those parentheses. When you see the parentheses, what do? Draw those two, whoop, whoop. Draw those two lines. What are we distributing in this one, though? There's a 5 here, a negative 5. What's here? Oh, very good. You guys remember, boom, there's a negative 1 right there. We're going to distribute the negative 1. Sebastian, what do I do with this 6?
Oh, you dropped that.
You just, oh, look, you learned from earlier, remember? Bam, nice. You just bring it down. Now distribute the negative 1. Negative 1 times 4. Negative 4. Negative 1. What the heck is this?
Negative 1x.
Same thing, right? There's a negative 1 in front of there if we don't have it. A negative 1 times a negative 1 is a positive 1x. The x is attached. Equals 3x minus 5. All right? 6 minus 4 is 2. We combine like terms and simplify before you start solving. Don't start trying to move stuff around to the other side and moving variables to one side or the other side until it's simplified. Otherwise, you're going to be doing way too many steps. Simplify, which means I'm only going to have a couple terms over here. 6 minus 4 is 2. 2 plus 1x equals 3x minus 5. Now, it looks just like this problem. X term on each side and a number on each side. There's an X term on each side and a number on each side. I don't want an X term on each side.
You're gonna have to do something.
Move it, right. People are saying it. I can hear it. People are saying add it, subtract it. Sebastian's had his hand up for 28 minutes. Oh, okay. 30 seconds. Good. 28 seconds. There we go. Go ahead.
You subtract 3x on both sides.
Okay, what if I wanted to subtract x?
So, no.
No.
For me, x always is on the
You like the x on the left.
Yeah.
Right. Some people, though,
are insane and like on the right.
Some people, though, like to move the smaller variable to the larger variable side because then you could avoid doing negatives, right? Like if I subtract 1 from 3, I get a 2x over there. But if we bring the 3x over there, we get a negative 2x. Uh-oh, negative 2. I might be scared of a negative 2. You know what I mean? All right. So, yeah, it doesn't matter. You can move it to either side. All right? We're going to do the opposite of what Sebastian said, just to annoy him. I'm going to bring that over there. It's plus 1x, minus 1x. It's gone on the left. On the right, 3x minus 1x is 2x minus 5. Notice we're only doing the opposite operation when we're doing it on both sides and moving it to the other side. Now it's a problem just like this, just like this. Add or subtract something to the other side, then divide. So we're going to add 5 to both sides. 2x equals 7. Divide both sides by 2. X equals 7 halves. You can write 3.5. I don't even care if you write 3.5. Boom, 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 boom. Okay? So simplify. Get the variables on one side and then solve like we've been doing all the other ones. All right? I'm going to put 2 more problems on the board. You guys are going to work on those for a few minutes. Okay? Look at this awesome, clean board.
Done.
Well, it's these markers. They got these low odor markers now, which don't smell bad, but they also don't erase as good. Or is it they don't erase as well? They don't erase as good. They don't erase as well. It's all well and good. That spray is for a disinfectant, though. Yeah, but it could be like maybe that's what's ruining the board. Maybe not. Okay, hold on. Where are we at? What number? Number 5? All right, 2 more. 5 and 6. I want you to practice 2 on your own. There we go.